Hello and welcome to lecture number 30 in the course User Centric Computing for Human Computer Interaction. So, what we have discussed in the previous lecture, we started our discussion on how to evaluate user centric designs, and there we mentioned that there are many evaluation techniques, there are different ways to view those techniques. One way is to view the techniques in the form of this hierarchy, where we have two broad categories: evaluation without users and evaluation with users. Under evaluation without users, we have expert evaluation techniques and model based evaluation techniques. Under evaluation with users, we have evaluation with self reports and empirical studies. There is another way to view it. So, we broadly have three categories: semi-automated methods, non-automated methods and automated methods. These terms indicate the methods that we apply to analyze the data that we collect during evaluation. Now, under semi-automated method, we have empirical studies. Under automated method, we have model based evaluations, and under non-automated methods, we have expert evaluations and evaluations with self reports. Among them, we have already discussed in the previous lecture expert evaluation. So, today we are going to discuss about the remaining methods. Let us start with user evaluation. So, with expert evaluation, we rely on data that is provided by those who are not likely to be the users of the system. For example, the designers or the other skilled designers. If you include some end users, of course, that is a separate thing, but mostly when we perform expert evaluation, typically those who are not likely to be the end users are involved, although they are skilled in their field. However, it is all right in the early phases when we need to go for rapid prototyping and evaluations, and there are many iterations. But of course, it is a fact that we are likely to get more insight if we collect the data from the users themselves. That is obvious. So, how we can collect data from the users? One way is to go for empirical studies. We have already discussed it before. What it requires is elaborate setup and expertise to collect and analyze the data. There is another way which is much less complex, which is directly get feedback from the users by asking them questions. Now, when we are going for this approach, where we are asking the users questions and taking their feedback on those questions, rather than asking them to perform some tasks, we log their data, then analyze it as we do in empirical study. That approach is known as evaluation with self reports. So, how we can do this? The data that we collect in this method is sometimes called subjective or preference data. The question is how we can do this. Let us try to see. So, there are many ways. One is we can ask for their rating on a scale such as a Likert scale, which we have already discussed before. Then we have a design and we can ask them to choose from a list of system attributes that they want to have in the system, or we can ask open-ended questions such as what you feel about the system or how we can make the system better. Earlier we have discussed the problem with open-ended questions. there is no guarantee that the feedback that we get is reliable. On the other hand, feedback we receive through some rating scales, we can generally consider such feedback to be more efficient and reliable. So, when we are going for feedback and if we are using a rating scale to get the ratings as feedback, this is considered to be more efficient and reliable than going for feedback through open ended questions. But the problem is collection of feedback with rating scale is also not easy, and there are broadly two issues. What are these issues? First of all, when we say that we want to collect ratings, what we mean is that we are collecting ratings on some items which are some questions or statements. For example, we may like to collect rating on a 3-point Likert scale for the statement, the controls are easily accessible. So, the prerequisite for going for rating based feedback is that we need to identify these items or questions or statements. So, they are most often known as a questionnaire, although it is not necessary that the items refer to any questions, it may be some statements also. And as is obvious, it is always a challenging task to identify suitable questionnaire for ratings. There is another issue. So, when we ask for feedback, we assume that the user is already exposed to the system. And how we can expose the user to the system? Let us consider a control study where we ask the user to use the system before feedback. And use the system means they are asked to perform some tasks. Now, when they are performing tasks and when they finish performing the tasks, these two are different points of interest. So, after every task we can take their feedback, or at the end of the completion of all the tasks, or at the end of the session we can collect the feedback. So, there are 2 points for data collection. It is always desirable to collect data at both the points, at the end of every task and at the end of the session. However, that may not be possible always, but if that is possible, then the corresponding questionnaire need not be the same, they may be different. So, the questionnaire that we use to collect data at the end of every task and the questionnaire that we use to collect data at the end of the session may be different. So, that is challenging to come up with 2 sets of questionnaires to collect data at different points. There are advantages and disadvantages for both the points of data collections. So, if we collect feedback after each task, then we are likely to pinpoint some problems with respect to specific tasks and parts of the interface used, because the users are likely to remember problems related to that task and the parts of the interface that they have used to carry out the task better just after each task. So, if you ask them to pinpoint problems related to tasks or parts of the interfaces after a long time, they may have forgotten many things and may not be able to give you proper rating as feedback. But as I said, this approach may not be possible always. If there is a large number of tasks given and the user's time is very precious, so after every task if we ask the user to give feedback, then the entire process may take long time, which the user may not be able to afford. On the other hand, the post session feedback is more common So, at the end of all the tasks we typically ask for feedback, but if we go for that, then we are more likely to learn about user perception on overall system rather than about specific tasks or portion of the interfaces. Now, that overall perception may not be relatable to any specific task or components of the interface. So, we may be interested to find out a specific task or specific components that may create problem, but from the overall impression it may not be possible to identify specific things in the design. Having said that, let us now try to see the issues concerning design of questionnaires. So, as I said, identifying a suitable questionnaire is challenging. Fortunately, there are already many standard questionnaires available and we can make use of those rather than trying to design it ourselves. Now, these questionnaires are available for both the points of data collection, namely post task and post session. So, for post task there are two popular questionnaires available. After scenario questionnaire or ASQ, it was proposed by Lewis in 1991, and expectation measure proposed by Albert and Dixon in 2003. There may be many other questionnaires available, but these two are well known. Similarly, for post session data collection, we have many questionnaires available. The more popular ones are System Usability Scale or SUS proposed by Brook in 96, Computer System Usability Questionnaire CSUQ proposed by Lewis in 95, Questionnaire for User Interface Satisfaction or QUIS quiz proposed by Chin et al. In 1988, and Usefulness, Satisfaction and Ease of Use Questionnaire or USE proposed by Lund in 2001. Again, these are not the only questionnaires available for collecting feedback at the end of the session. There are many other questionnaires, but these are popularly used and well known. In order to get some understanding of these questionnaires, we will go through a couple of them, one for each category. So, we will discuss the ASQ questionnaire and the SUS questionnaire to give you an understanding of how the questionnaires are designed and how they are used. Let us start with the post task questionnaire ASQ. Now, this questionnaire consists of 3 statements and each user is asked to provide a rating on a 7-point rating scale for each statement. So, in this rating scale, rating 1 indicates strongly disagree and rating 7 indicates strongly agree. What are these statements? The first statement is, I am satisfied with the ease of completing the tasks in this scenario. Second statement is, I am satisfied with the amount of time it took to complete the tasks in this scenario. And the third statement is, I am satisfied with the support information, online help, message, documentation when completing the tasks. These are the 3 statements which form the questionnaire, ASQ questionnaire. For each statement, at the end of each task, the user is asked to give a rating in a 7-point rating scale, where 1 indicates strongly disagree and 7 indicates strongly agree. One thing you may note here is that the questions are very simple. It is so since it is designed to collect quick feedback, because the feedback is supposed to be collected at the end of each task, and therefore, it has to be collected many times. So, to make it quick, very simple statements have been used to form the questionnaires. Now, once we collect rating, what to do? There are two ways, but before that, let us see how they are related to usability. The first statement can be related to the effectiveness measure of usability. The second statement can be related to the efficiency measure of usability, and all the three taken together can be used to represent satisfaction. So, these three, as you may recollect, are part of the definition of ISO standard. So, these three measures, effectiveness, efficiency and satisfaction, refers to the ISO standard definition of usability, and this ASQ questionnaire is designed to help identify or help evaluate these components of usability. And how we can use the feedback received through ratings? We can consider the average ratings for each statement, that is one way. The other way is we can consider average rating for all the statements taken together to come to a conclusion about the overall usability of that particular system with respect to the particular task. So, the idea is that if we get these ratings for each task at the end of each task, then at the end of the session we can actually go through these ratings, find out the task for which the rating is very poor, and for those tasks we can actually try to figure out why the ratings are poor, why the users felt that the system is not usable, which components of the interface were part of that task, and how to improve those components. So, in other words, with these ratings the designers will be able to identify specific problem areas in the overall design. Now, that is about post task questionnaire example. Let us now move to post session questionnaire example, that is SUS or system usability score. Now, SUS consists of 10 statements. Earlier in ASQ we had 3 statements, here in SUS we have 10 statements. One important thing is that among the 10 statements, half or 5 are positively worded. These are statement numbers 1, 3, 5, 7 and 9, we will soon see. And the other half or the remaining 5 statements are negatively worded. These are statement numbers 2, 4, 6, 8 and 10. Let us now see these 10 statements to understand these concepts. These are the 10 statements for SUS questionnaire. The first statement is, I think that I would like to use this system frequently. As you can see, this is a positively worded statement. Second statement is, I found the system unnecessarily complex. This is a negatively worded statement. Third one is, I thought the system was easy to use. Again, this is a positively worded statement. And fourth is, I think I would need the support of a technical person to be able to use the system, which is a negatively worded statement. Similarly, the fifth statement is a positively worded statement which says, I found the various functions in this system were well integrated, whereas the sixth statement is negatively worded and says, I thought the system was too inconsistent. Seventh statement is, I would imagine that most people would learn to use the system very quickly, whereas eighth is a negatively worded statement which says, I found the system very cumbersome to use. Ninth statement is, I felt very confident using the system, and tenth is, I needed to learn a lot of things before I could get going with this system. So, in these 10 statements, the positively worded statements are shown in bold font and the negatively worded statements are shown in regular font. So, 1, 3, 5, 7 and 9 are positively worded, and 2, 4, 6, 8 and 10 are negatively worded. Together they constitute the SUS questionnaire. For each question or for each statement in the questionnaire, the feedback is collected on a rating scale, which is a 5-point rating scale, also called an agreement scale, which is a Likert type scale, where 1 indicates strongly disagree and 5 indicates strongly agree. So, at the end of a session, each participant in the study is given this questionnaire and their ratings are collected for each of these 10 statements. Then we need to combine these ratings, and after combination we get a score which is an overall SUS score, which indicates the usability of the system. Now, the combining the ratings is not a straightforward thing, it is tricky, and we will go into the details of this combination process. This is unlike the ASQ rating, where we can simply take some average and that is all, but here we require to do some other things. First thing that we need to do is to sum up the contributions for each statement. In order to do that, we should be able to find out the contributions for each statement, which is an integer and lies between 0 to 4, and these contributions are actually of two types. So, accordingly there are two components to calculate these individual contributions. For positively worded statements, individual contribution for each statement can be calculated as the rating obtained minus 1. So, if R indicates the rating, then for each statement we will get the individual contribution by the formula R minus 1. For negatively worded statements, the contribution is calculated as 5 minus the rating. So, it is 5 minus R. The equation shows the overall calculation. So, here S is the SUS score. There are two components for positively worded and for negatively worded. Ri indicates the rating for ith statement, where I ranges from 1 to 10. Now, for positively worded, there are 5 individual components, all these are summed together. Similarly, for negatively worded statements, there are 5 components, and for each we calculate the contribution with this equation, and then we sum them together. Then these two components are added So, we calculate an overall sum and then we multiply this sum with a factor 2.5 to get the score. As an example, let us consider these ratings that we have received for a particular system. For statement 1, we got a rating of 5, for 2 it is 4, for 3 it is 2, for 4 it is 1, for 5 it is 2, for 6 it is 3, for 7 it is 2, for 8 it is 4, for 9 it is 5, and for statement 10 we received a rating of 2. Now, the ratings for positively worded statements are shown in bold and the ratings for negatively worded statements are shown in regular font. So, with these ratings we can use the equation to calculate the overall SUA score. So, first we find out the individual components for the positively worded statement using the equation R minus 1. So, rating minus 1 and we get 11. Then we find out the overall contribution by the negatively worded statements by summing up the individual contribution for each statement using the equation 5 minus R. So, here we get the same value incidentally for this component as well, that is 11. Then we add the two components and get 22. We then multiply it with this factor 2.5 to get this overall score 55. Now, what 55 tells us? We can interpret the score as percentage. So, when we say that we got a score of 55, we can say that the score is 55%, and it is generally assumed, it has been found that a score around 70% or more is desirable. So, if we get a score which is less than this value, then it indicates there may be some usability problems. Where exactly the problem is, it cannot tell, which is anyway the characteristics of a post session feedback mechanism, but it can tell that there are some problems and the designer has to go through the design again minutely to find out the source of the problems. Now, that is about evaluation with self report. So, we have discussed two evaluation methods. One is expert evaluation, one is evaluation with self report, where we involve the users. So, in the hierarchy of evaluation methods, so we have discussed expert evaluation and evaluation with self report. In expert evaluation, we discussed about cognitive walkthrough and heuristic evaluation. With self reports, we talked about post task and post session questionnaire and feedback based on rating scales, and we discussed couple of standard questionnaires, namely the ASQ and the SUS. What is left is the other methods, namely the empirical studies and model based evaluation. So, we have already discussed these methods before. Let us just quickly recap what we have discussed. Now, when we talk of empirical evaluation method, we essentially refer to hypothesis testing. As we discussed in details in a previous lecture, it involves 4 stages. So, we start with identification of research questions, and this is followed by framing of hypothesis from each question. Then we determine the variables for which we want to observe and record data. So, we determine dependent variables, independent variables, control variables and confounding variables. Then we go for the design of our experiment. So, in the design, several things are taken into account, namely how many participants, what kind of tasks, in which order the tasks are to be given, whether the experiment should be within subject or between subject, and so on. And finally, we go for analysis of empirical data. Essentially, this stage refers to the analysis of data for testing of statistical significance, so that we can refute the null hypothesis and support alternative hypothesis. And this alternative hypothesis essentially refers to a quality which supports usability. So, the overall objective of empirical study is to evaluate the usability of the system in terms of hypothesis testing, or in terms of supporting alternative hypothesis through statistical means by collecting data in a controlled environment. The other evaluation technique is model based. Now, we already have discussed this in an earlier lecture like empirical studies, and there we discussed about case studies on virtual keyboard design. Let us just quickly recap how we can evaluate a design using models. So, we talked of two models. One is the Fitts diagram model. This was developed to evaluate performance of single finger typing on a mobile device using virtual keyboards. There, the model is separate for a novice user and an expert user. For novice user, we can compute performance in terms of character per second using this equation, where RT is choice reaction time and MT is the average movement time between keys on the layout. Whereas, for expert, we can compute performance by this expression, where CPS is the character per second, MT mean is the average movement time between keys on a layout. And the choice reaction time or the reaction time can be computed using the Hickman law. The average movement time can be computed with help of the Fitts law and the digraph probability distribution found from a corpus. So, what we evaluate? We evaluate the performance, and in this case the performance is represented in terms of characters per second entered by the typist, or character per second which is likely to be entered by an average typist, which, as we have discussed, is related to the measure of usability. Similarly, we have talked about thumb typing model for mobile typing. This model is somewhat different. So, it is a combination of equations and algorithms to compute the overall performance. The equations are recursive. Tn indicates the time required to type using two thumbs, n characters, which is represented using these two equations. It has two components. If we are using same thumb, the top component is applicable. If we are using opposite thumb, then the bottom component is applicable. T1 is the time to type the first character, and there are some model parameters which are found empirically. And once we are able to compute the time to enter n characters, using that we can compute overall performance in terms of characters per second through an algorithm. So, these two case studies for model based evaluation indicates that we can apply the models to find out the usability, but in a limited sense, only with respect to some components of usability. But eventually we have to go for a thorough empirical study at the end. Whatever we have discussed today can be found in this book. So, In today's lecture as well as the previous lecture, we have covered different evaluation techniques. All these techniques can be found in this book. You are advised to refer to chapter 9. For today's lecture on evaluation with self report, you can refer to section 9.3. However, you are also advised to go through section 9.4 and 9.5 for a better understanding of model based design. That is all for today. Thank you and goodbye.